Hello everybody, welcome to your Unit 2 Section 6 Chem Talk. We're going to be focusing on factors that affect the rate of reaction. And we should be on page 31 of our green sheet, so hit the continue button when you are ready to go. So when we're talking about rate of reaction, what we mean is how fast or slow is the reaction occurring. Right? Rate is just our speed at which the reaction is taking place. And this is important, especially in the pharmaceutical industry. The faster that you can produce chemical reactions, the faster you can make your products. So the more you can sell, the more people you can help. Same thing with a lot of other businesses and industries. The faster we can do anything, the more we can do of it, and the more productive we can be, and the more money we can make to make sure our businesses are viable. Okay, so that is why rates of reaction are so important. We have four factors that will affect the rate of the reaction. They are the concentration, and that's just telling us how strong or diluted our solution or chemicals are going to be. Right? The use of a catalyst, a change in temperature, and the amount of surface area. These are the four factors that can affect the rate of a reaction. You might want to star those. Alright, so even though we haven't done the investigate yet, we're going to do a little bit of a preview. And then that way, as you do the investigate, it will make some sense as you go through. So for the first part of our investigate, we're combining hydrochloric acid with magnesium. Alright, and this is testing the concentration. Okay, so we'll fill in the concentration notes as we go through. The higher the concentration, the faster the rate of the reaction is going to be. So as we increase the concentration, it means that we are increasing the number of particles in our reaction. So a lot of times I like to think of orange juice as an example of concentration. So for an old man like me, if I drink some orange juice straight out of the container, it is quite acidic for me and I get some heartburn. So I need to make the orange juice less concentrated by putting a little bit of water inside the glass. I know, I sound so old. And that will lower the concentration because it will lower the amount of orange juice particles in my glass, and I will be less likely to get heartburn. So the more particles we have, the more they can interact with each other, and the faster the reaction can take place. If we have less of them in a given area, it takes longer for them to interact with each other. So here's a little example. If we have a low concentration, there's less collisions, so we have less chemical reactions taking place, but the more particles we can put in a substance, the more particles can collide with each other and start that chemical reaction. This causes more particle collisions, would be our last blank for concentration. Alright, our next example of rate of reaction from our investigate would be using hydrogen peroxide and light, and this is going to talk about catalysts. So catalysts speed up a reaction without being permanently changed or consumed. You can kind of view a catalyst as like a spectator in the chemical reaction that's cheering them on and making them work faster, but not actually taking place in the chemical reaction. So a really good example would be the catalytic converters we have in automobiles. So these are made of platinum and rhodium. And what happens is, through the combustion reaction that powers your vehicle, sometimes there's an incomplete reaction. So instead of producing carbon dioxide, CO2, your car will sometimes produce carbon monoxide, CO. And this can be quite bad. Carbon monoxide is quite dangerous, especially as a product in our environment. So what the catalytic converter will do is it will help attach an extra oxygen to the carbon monoxide to produce carbon dioxide. So it's speeding up that reaction, and catalytic converters have actually drastically lowered the amount of acid rain that we have, especially here in the Northeast. One of the best inventions we've had in the past 50 some years is the catalytic converter. Alright, so the big thing here to know is that catalysts do not participate in the reaction. Okay, they are not a reactant, they are not a product. If we were writing them in the chemical formula, they would go above the arrow to show that they are not actually in the reaction. Alrighty, so here's a picture of what we have in our catalytic converter. So we have carbon monoxide, right, as one of my reactants coming through, right? Or actually, it would be one of my products of the reaction. Right? And as it passes through the catalytic converter, right, the catalytic converter helps attach oxygens to it. So we get, not only are we getting rid of our nitrous oxides and making them, right, N2s, we're breaking that apart and taking the oxygen from the nitrous oxide and attaching it to the carbon monoxide, right? So that we're getting mostly clean-ish products, right? We know carbon dioxide is not great for the environment, but if you compare the effects of carbon dioxide to nitrous oxides and carbon monoxide, right, it is lesser. Okay. These catalytic converters are very expensive because of the precious metals that they are made of. Now, don't think that you can go around your neighborhood and chop off people's catalytic converters, because we try to do that. No place is going to buy your catalytic converters. They know how they can often be stolen. So if you walk into, right, like a scrapyard or something with a catalytic converter, they're going to report you or they will turn you away. Okay. All right. So for our third part of the investigate, we're going to examine temperature and how that will affect the rate of our reaction. We've already looked into this a little bit before. I don't know if you remember doing the little activity with the hot water and the cold water and looking at how the hot water spread faster. Right, so our lab is going to be quite similar. So the higher the temperature, the faster the rate of reaction. And we know this, right, because when the temperature increases, so does the kinetic energy. So the warmer our temperatures, the faster our particles are going to be moving. Right? The colder it gets, the slower they're going to move. Right? So when we have more particle movement, we're going to have more collisions between our particles, thus increasing the rate of the chemical reaction. Right? It will cause more frequent and harder collisions. Alrighty. And lastly, our fourth change is going to be surface area, and changing the size of particles changes the surface area. Alright, so the results of this is not always perfect, but we did do a little bit of an example for you guys in class. So when we were doing the exothermic demo in class, you might have noticed Mr. Arrow or myself grinding up the potassium permanganate, that purple crystal, in the mortar and pestle. And the reason we were doing this is the smaller we can make those pieces of potassium permanganate, right, the faster the reaction can occur, so we're not standing outside the fume hood for 5 minutes waiting for the glycerin and the potassium permanganate to react together. Alright, so even though a large cube looks like, right, it has more area exposed, it actually has less surface area if we break it down into smaller pieces. Alright, because right now in our large piece, only the outside is exposed. But when we break it down into 8 smaller pieces, like this example, right, it doesn't always have to be 8, we not only still have all the outside exposed, right, but all of these inside parts are exposed as well, thus increasing our surface area, right. The volume is still the same, right, the mass will still be the same, just making these smaller pieces increases my surface area. Okay, so our surface area for the first one would be about 96 centimeters cubed, while total surface area, for if we just chop it into 8 pieces, right, more than doubles. It's 192 centimeters squared. Okay, so again, the greater the surface area, the smaller particle size, the faster the rate of the reaction is going to be. Alright, so if we're looking at these pictures here, which one of these two reactions do you think would happen faster? The one with the large piece, right, in here, or with the smaller pieces, right? Even if they have the same amount of particles, right, you should have said that the Smaller pieces, right, with the magnesium are going to react faster with the acid. Alrighty, and that's because the smaller pieces have a high surface area and the large piece has a low surface area. Right, so the smaller particle size increases the number of collisions. And you can see that because, well, these ones are just stationary, stuck here, right? Our acid, the red particles, can only come in contact with the outside, while smaller pieces, right, has access to interact with the acid all over the beaker. Alrighty. That's going to be it for the Chem Talk for today. Make sure after you watch this video you are also completing your Chem to Go on page 32 in your green sheet. And that's it. Have a great rest of your day.